Okay, so someone wanted to see problem number 24 worked out, and this was the third of three problems in a row here that all dealt with this same figure. In the book, it's figure 19. Asking you to find, it asked the same question in all three. Find the points of inflection in the graph of f and state the intervals on which f is concave down. Now, the difference between 22, 23, and 24 was that in number 22, they asked you to assume that this was the graph here of y equals the original function f of x. So that was in 22. I think that was probably the easiest one because you're really just looking for points of inflection, which were right here at C, where we went from being concave downward to concave upward like this, and that was really it, I think. So that was 22. I thought that 23 was probably the hardest of the bunch right here, because in 23 they wanted you to think that this was the graph of y equals f prime, the derivative. So it got a little trickier here. I think that 24, which we're going to do right now, is probably a little bit easier than 23, but I could be wrong about that. Let's see what's going on here. So we're trying to find points of inflection, and I should have written this out. Points of inflection in the graph of y equals f of x. And they want us to assume here in number 24 that this figure that's been drawn is not the graph of the original function, but that this is y equals f double prime. This is the graph of our second derivative. So if we want to be able to find points of inflection, I'm not looking at points of inflection in the graph of this one right here. What we want to understand instead is that a point of inflection in the graph of f happens where its second derivative, f double prime of x, changes sign. In fact, I'm going to write that out. We would say that f, this is the kind of justification we're normally going to do on the AP test, f has a point of inflection, and I always want to say when, but really the word is where. F has a point of inflection where f double prime changes sign, either from positive to negative or from negative to positive. So remember, guys, this red curve we're looking at is the graph of f double prime. So where does this graph change sign? Once right here at A, where the graph was below the x-axis and is now above the x-axis. So this occurs at x equals A, and then where else? This graph is positive from A until we get to this point right over here. So x equals D is another spot where our second derivative changes sign. And then once again, we have another one of those points of inflection right here at F, where this graph, our second derivative, now changes from negative to positive. So these would be the same three, the only three spots right here where we have points of inflection. At A, and at D, and at F. Because again, this is the graph of the second derivative, and those are the three spots where this graph changes sign. Then, the other part of the question, although it goes right along with this, where is this graph concave down? So let me go ahead and state this here again. F is concave down. Always a good idea to start with the justification. Is concave down, and again, not when, but where. So let's think about this, guys. What makes a function concave down? Its second derivative, f double prime, has to be negative or below 0. And where does that happen here? Looks like it happens once on this interval right over here. This second derivative graph is below the x-axis, so it's negative. So it looks like that happens here on the interval from, I would say, from 0 to A, and then we've got another interval of negativity here for this graph here on an interval then from D to F. All right, and technically there'd be a U right there for union, but I don't think anybody's too worried about that, but that's where we would be concave down. So those are going to be the answers then, guys, to problem number 24, and I think that's a really interesting problem. I like it a lot, but it's probably better if we look at it within the context of the answers to 22 and 23, because those problems, the answers are going to be different for all three, depending on which function it is that we're actually looking at. In this case, with f double prime, that's our answer then for 24.